Hello everyone. So let's look into the second example of the capacity calculation. So this time from a manufacturing firm. So this is question number 2 in your worksheet. So in this scenario, we have 3 furnaces which are used to process silica by 3M. And these furnaces are available 24 hours a day, 5 days a week. And each furnace can process 2200 pounds per hour, right? So that's the capacity of a furnace per hour. So there's some information given on preventive maintenance where the furnace is taken down for the preventive maintenance around 65 hours per week. And there's another downtime of 39 hours per week. So from here you can get an indication that you need to convert everything in the terms of per week. Then you're given the effective capacity as 1.7 million pounds and actual production is 1.6 million pounds of silica per week. So I'll come back to that and I will explain that a little bit from the demand and capacity viewpoint. Then you want to calculate the total design capacity per week. So from here we need to convert everything to per week. Okay, so in this case we want to calculate the utilization of furnaces during a week. So if you have a question of a utilization where you're asked to calculate utilization during a period, so for that you're going to use the formula utilization during a period is equals to uptime divided by the available time. Okay, so let's start calculating the design capacity per week. So for that, let's get the available hours, as we need to do everything per week. So the available hours per week are going to be, so we have 8 furnaces which are operating 24 hours 5 days a week. So that's all given here, right? So that will give me 960 hours per week. So from here we can calculate the total design capacity per week, because we already know that each furnace can process 2200 pounds per hour, and we know that we have 960 hours available for the entire week for 8 furnaces. So I want to put here total design capacity per week. We have furnaces can process 2200 pounds of silica per hour and we have 96. So that's going to give you around 2.1 million pounds of processing capacity per week, right? So from here the next thing is to calculate the utilization. So the utilization is uptime divided by the available time. So we already know that the available time is, so available time is already calculated. We have available time per week 960 hours. So from here we can calculate the uptime. We know that from the scenario that there's a preventive maintenance 65 hours per week and there's a downtime of 39 hours per week. So the uptime is going to be 960 minus 65 hours for the preventive maintenance minus 39 hours as downtime. So I have 856 hours uptime, so which is available for this furnace to be scheduled for the production. So let's take this ratio. So 856 divided by 960. I'm going to get here the average utilization per week as 89%. Okay, so I want to rearrange this a little bit so that we can explore this concept further when we look into the efficiency and the second formula for the utilization. So we have some other information here. We have information that the effective capacity is 1.7 million pounds per week, right? And the actual production is 1.6 million pounds per week. Okay, so before we look into the efficiency part, let's explore this a little bit more to clear some of the concepts. So we have here uptime that we calculated as 850 hours per week. And we know that we can process 2200 pounds of silica per hour. So if the uptime is 850 hours per week, and if I multiply that by 2200 pounds per hour, so I'm going to get capacity, effective capacity, based on this uptime, which is around 1.8 million. However, you're given with the effective capacity of 1.7. So why there's a discrepancy? So when we talk about the operations, I'm going to take you back to the very first chapter about the transformation process. In this case, is the furnace or the silica furnace. You have demand here, and there are the constraints on the system, such as there may be rework, quality problem. You may need to take some time to move silica into the furnace and out of the furnace. So that's why this figure is a bit smaller than what we have here. That's why these numbers are slightly different, the 1.6 million and 1.7 million, instead of if you're calculating these based on the uptime. So let's get the efficiency. So efficiency is going to be the ratio between actual output rate and the effective capacity. So the actual output rate is 1.6 million and the effective capacity is 1.7 million, right? And that's going to give me efficiency of 94%. Okay, so when you're solving these problems, do not multiply uptime with the capacity per hour, right? Because the effective capacity will consider the other constraints too, which are not given here based on the given scenario, right? So that was, I believe, kind of lost when we were discussing this question. So let's calculate the utilization based on the actual output rate. So the formula for that is utilization equals to actual output rate divided by design capacity. So the actual output rate is given here, 1.6 million. Design capacity in terms of number of units being processed per week, we already calculated that. So that was around 2.1 million. So it's going to become approximately 75.75%. So one quick note before we close off this part. So the utilization that you will get based on the actual output rate, where we have considered the defected parts, the actual output rate is influenced by the demand or rework that needs to be done, or the transportation of parts from one machine to another will have an impact on the output rate. So which means the utilization you're going to get from the actual output rate is going to be less than utilization obtained from the uptime. This is the utilization for a period. This is utilization based on the actual output. So similarly for the hospitals, restaurants, the utilization will vary based on demand. Okay, so if you still have questions, please feel free to reach me out, and you can ask me during the next live session. Thank you very much.